welcome back to the Snoozing Scientist. Before we begin tonight's journey, I'd love for you to leave a comment down below and let me know where you're tuning in from. Whether you're listening beneath city lights, beside the ocean, somewhere deep in the countryside, or halfway around the world, it's always fascinating to see where our fellow sleepy scientists are gathering each night. Now get comfortable. Settle into your favorite spot. And for a little while, let your mind wander somewhere quieter. Imagine a forest at the very edge of night. The sun disappeared below the horizon some time ago, leaving behind only the faintest traces of blue in the sky. The daytime world is beginning to fade. The songs of robins and sparrows have grown quiet. The squirrels have vanished into their nests. Even the insects seem less hurried now. The forest is changing. Not becoming empty. Just becoming different. For most creatures, darkness signals the end of activity. For an owl, darkness is an invitation. High above the forest floor, hidden among the branches of an old tree, an owl waits. At first glance, it doesn't seem particularly remarkable. It isn't moving. Its feathers blend almost perfectly with the bark surrounding it. The patterns across its body break apart its outline so completely that it looks less like a bird and more like a piece of the tree itself. If you were walking beneath it, you might never notice it was there. And perhaps that's part of what has fascinated humans for thousands of years. Owls have always seemed to appear from nowhere. One moment the forest is empty. The next moment, a pair of eyes is staring out from the darkness. Ancient people noticed this too. Long before biology existed as a science, long before anyone understood evolution or adaptation, owls had already earned a reputation as creatures of mystery. The ancient Greeks associated them with wisdom. Across many cultures, they appeared in stories, legends, and folklore. Some saw them as symbols of knowledge. Others believed they were guardians of hidden things. And standing beneath a moonlit forest thousands of years ago, it's easy to understand why. Because even today, owls seem different. The bird sitting quietly on that branch is experiencing the night in a way that few other animals can. The first thing you might notice are its eyes. They seem enormous, almost impossibly large. In fact, if human eyes were scaled to match the proportions of an owl's body, they would be closer in size to oranges than eyeballs. Those enormous eyes are one of the reasons owls have become masters of darkness. Every bit of available light, moonlight, starlight, even the faint glow reflecting from clouds, is gathered and focused. To us, the forest might appear dark. To the owl, it is filled with detail. Shapes emerge from shadows. Movement becomes visible. The landscape remains readable long after the sun has disappeared. Yet oddly enough, those famous eyes come with a limitation. They don't move very much. Unlike humans, who can glance in different directions without moving their heads, an owl's eyes are fixed in place. Which explains one of the strangest things about them. Slowly, almost silently, the owl begins to turn its head. Farther. Farther. And farther still. The movement feels almost impossible. But hidden beneath those feathers is a neck unlike almost any other bird's. Additional vertebrae and specialized blood vessels allow the owl to rotate its head far beyond what most animals can manage. It isn't a trick. It isn't magic. It's simply nature solving a problem in a very unusual way. The owl finishes its slow turn and becomes still once again. But although the body hasn't moved, something else is constantly at work. The owl is listening. Far below, hidden beneath layers of fallen leaves, a mouse is moving through the darkness. The sound is incredibly small. A faint rustle. A soft step. Almost nothing at all. Yet the owl hears it. In fact, many owls possess hearing so precise that they can determine not only where a sound came from, but also its height, depth, and direction with astonishing accuracy. The forest, which seems silent to us, is alive with information. Every rustling leaf, every snapping twig, every tiny movement. And the owl gathers all of it. Patiently. Quietly. As though the darkness itself is speaking. And somewhere below, completely unaware, the mouse continues its journey through the leaves. While above, the owl waits for exactly the right moment. The mouse pauses beside a fallen log, unaware that high above, every movement it makes is being carefully tracked. The owl doesn't react immediately. That's one of the most surprising things about owls. For animals often portrayed as fierce hunters, they are incredibly patient. An owl may spend long stretches of time simply observing. It waits for certainty. It waits for the right opportunity. Every movement costs energy, and over millions of years, owls have become experts at conserving it. The forest remains still. The mouse takes another step. And then, almost without warning, the owl leaves the branch. Not with an explosive burst of motion. Not with a dramatic rush of wings. Instead, it simply seems to separate from the tree. One moment it's perched among the branches. The next, it's floating through the darkness. This silence is one of the greatest marvels of the natural world. Scientists have spent decades studying owl feathers, trying to understand how something so large can move through the air so quietly. Along the front edges of their wings are tiny comb-like structures invisible from a distance. These break apart turbulent air before it can create noise. Other feathers absorb sound instead of reflecting it. The result is extraordinary. An owl can fly so quietly that sometimes even nearby animals fail to realize it's there. To us, silence often feels empty. To an owl, silence is a tool. The owl glides low across the forest floor. Then, just as suddenly as it appeared, it vanishes into the darkness once more. Far above, the moon continues climbing. And somewhere deeper within the forest, another owl calls. The sound drifts through the trees. A low, haunting note. Then another. Then silence again. Many people assume all owls make the familiar hoo-hoo sound. But the truth is far stranger. There are hundreds of owl species across the world, and many sound nothing alike. Some whistle. Some bark. Some chirp. Some produce eerie screeches that can startle even experienced hikers hearing them for the first time. The barn owl, for example, often doesn't hoot at all. Instead, it releases a long, raspy scream that seems to emerge directly from the darkness. For centuries, people hearing these sounds at night often imagine supernatural explanations. But the calls serve practical purposes. Some help owls locate mates. Others establish territory. And some simply announce presence. A message carried through the darkness. A reminder that another owl is nearby. The owl in our forest hears the distant call and turns its head slightly. Not because it's threatened. Simply because every sound matters. Every sound tells a story. And perhaps that is one of the most remarkable things about the world owls inhabit. It is a world built from details most of us never notice. A snapping twig. A rustling leaf. The distant splash of water in a stream. The movement of wings overhead. While humans often dominate the daytime world through vision, owls have become masters of another kind of awareness entirely. As midnight deepens, the forest grows cooler. Tiny droplets of moisture begin forming on leaves. Mist gathers between the trunks of ancient trees. And somewhere above it all, the owl settles once more onto a branch. This time, it is joined by another. Not every owl lives alone. During breeding season, many species form surprisingly strong pair bonds. Some couples remain together for years, sharing territories and raising young season after season. In the spring, hidden high within hollow trees or sheltered cavities, small owl chicks begin their lives. And unlike the silent hunters they eventually become, young owls can be surprisingly noisy. Hungry chicks constantly beg for food. They chirp, squawk, call out into the darkness. At first they are covered in soft down feathers, looking more like fuzzy balls than future predators. Their enormous eyes seem almost too large for their heads. Their movements are clumsy, awkward, uncertain. It's difficult to imagine that these fluffy creatures will someday become masters of the night sky. Yet over time, they grow. Their flight feathers emerge. Their hearing sharpens. Their instincts develop. And eventually comes one of the most important moments in an owl's life. The first flight. For young owls, this moment is rarely graceful. Many don't soar elegantly into the night. Instead, they stumble, flap wildly, miss branches, land awkwardly. They are, in many ways, learning exactly the same way humans do. Through practice, through mistakes, through repetition. And somehow, there is something comforting about that. Even one of nature's most perfectly adapted hunters begins life uncertain, learning one small lesson at a time, night after night. Until eventually, one evening, a young owl launches from a branch. And for the first time, the flight feels effortless. The forest stretches below. The stars shine overhead. And another silent traveler joins the ancient world that awakens after dark. Most people assume the owl's head-turning ability exists because the neck is unusually flexible. That's true, but it's only part of the story. The more surprising fact is that the entire system begins with the eyes. An owl's eyes are so large that they occupy an enormous portion of the skull. In some species, the eyes account for nearly a third of the weight of the head. If you've ever looked directly at an owl and felt that its eyes seemed oversized, it's because they genuinely are. The shape is unusual too. Human eyes are roughly spherical, which allows them to rotate freely inside their sockets. Owls don't have that luxury. Their eyes are elongated, almost resembling a pair of optical tubes extending backward into the skull. This design comes with a major advantage. More light can be gathered and focused onto the retina, which dramatically improves vision in low-light conditions. But every advantage in biology tends to come with a trade-off. Because those eyes are so large and deeply anchored, they are almost completely incapable of moving. Try something for a moment. Keep your head perfectly still and look as far left as you can with only your eyes. Now look right. You probably didn't think twice about it. Humans do this thousands of times every day. An owl can't. If it wants to examine something off to the side, the entire head has to move. That single limitation shaped millions of years of evolution. Over time, owl necks became increasingly specialized. While humans have 7 vertebrae connecting the skull to the rest of the body, owls have 14. The extra joints create additional points of movement, allowing for a range of motion that seems almost mechanical. Yet flexibility alone doesn't explain why an owl can rotate its head so far without injury. The real challenge is circulation. Your brain is incredibly demanding when it comes to blood supply. Even brief interruptions can cause problems. If a human attempted the same movements as an owl, major blood vessels would quickly become compressed or stretched beyond their limits. Owls solved this problem in an elegant way. Researchers examining owl anatomy discovered that certain arteries entering the skull are proportionally much larger than necessary. These enlarged sections appear to function almost like backup storage tanks, holding additional blood that can continue feeding the brain during extreme movements. Even the pathways through the neck bones are different. The channels that carry blood vessels leave extra space around them, reducing the chance that the vessels become pinched when the head rotates. It's one of those rare moments in biology where you can see multiple systems evolving together toward the same goal. The skeleton changed. The muscles changed. The blood vessels changed. Even the shape of the skull changed. All because the eyes couldn't move. And perhaps that's the most fascinating part. When people see an owl rotate its head, it looks like a single adaptation. In reality, it's the visible result of dozens of anatomical changes working together. A simple movement that took millions of years to perfect. The next time you see an owl slowly turning its head, you're not just watching a flexible neck. You're watching an engineering solution built by evolution itself, one that began with a bird that wanted to see more of the world without moving from its perch. One of the most surprising discoveries about owl vision is that, despite their reputation for seeing perfectly in the dark, owls don't actually possess some kind of supernatural night vision. In fact, if you could somehow experience the world through an owl's eyes, you might notice something unexpected. The image would probably not be especially colorful. It would not look brighter in the way a modern night vision camera does. Instead, it would be incredibly sensitive to small amounts of light. Owls have retinas packed with cells called rods, which are extremely good at detecting light in dim conditions. Humans have these cells too, but owls have far more of them. This allows them to operate during twilight, moonlit nights, and the dark hours before dawn when many other animals struggle to see clearly. The trade-off is color. The cells responsible for detecting color are called cones, and owls generally have fewer of them than many daytime birds. An eagle soaring beneath a bright blue sky experiences a world rich in color and detail. An owl experiences a world optimized for contrast, movement, and low-light awareness. It's another example of evolution making a choice. Not better, just different. And those differences become even more fascinating when scientists begin studying the owl's brain. A surprisingly large portion of an owl's nervous system is dedicated to processing sensory information. Sound, vision, movement, and spatial awareness all flow through highly specialized regions that help the owl understand where things are and what they are doing. Imagine sitting in a completely dark room. Now imagine someone drops a coin somewhere across the room. Most humans could roughly point toward the sound. An owl could often do far better than that. Experiments have shown that certain owl species can determine the location of sounds with astonishing precision, sometimes within just a few degrees of accuracy. The reason lies in timing. When a sound occurs, it reaches one ear slightly before the other. For humans, these differences are usually too small to consciously notice. The owl's brain, however, is built to measure them. Not milliseconds. Sometimes fractions of milliseconds. Tiny differences that allow the bird to calculate where a sound originated. The result is a kind of natural triangulation system happening constantly inside the owl's head. Every rustle, every scratch, every movement. The brain is continuously solving tiny calculations without the owl ever needing to think about it. And this brings us to another interesting misconception. People often describe owls as wise. The image appears everywhere: children's books, logos, stories, and ancient mythology. But owls are not considered particularly intelligent in the same way that crows, ravens, or parrots are. Crows can solve complex puzzles. Ravens can plan for future events. Parrots can learn surprisingly sophisticated forms of communication. Owls followed a different evolutionary path. Rather than becoming general problem solvers, they became specialists. Almost everything about an owl is focused toward a particular purpose. Their eyes, their ears, their feathers, their flight, their hunting behavior. Instead of being masters of many things, they became extraordinarily good at a few things. And in nature, specialization can be just as successful as intelligence. In some ways, it's even more impressive. Because every feature begins fitting together like pieces of a puzzle. Take the owl's facial disc, for example. That circular arrangement of feathers surrounding the face isn't there to make the owl look distinctive. It's there because sound waves bounce off those feathers and are directed toward the ears. The face itself becomes part of the hearing system. It's almost like having two built-in satellite dishes attached to the sides of your head. Some species can even adjust portions of the facial disc slightly, changing how sound is collected depending on what they're listening for. The deeper scientists look, the more interconnected everything becomes. The face helps hearing. The eyes influence neck movement. The neck influences blood vessel design. The feathers influence hunting strategy. Nothing exists in isolation. Every adaptation connects to another. And perhaps that's one of the reasons owls remain so captivating. At first glance they seem simple. A bird sitting on a branch. A pair of large eyes. A few soft hoots drifting through the night. But beneath that familiar image lies millions of years of evolutionary fine-tuning, creating an animal so perfectly adapted to its environment that nearly every part of its body tells the same story. Not a story about speed. Not a story about strength. But a story about perception. About gathering information from the darkness. About understanding a world that most creatures can barely detect. And somehow, the owl accomplishes all of this while appearing perfectly calm, as though none of it requires effort at all. There is another reason owls have fascinated scientists for so long, and it has less to do with what they can do, and more to do with what they choose not to do. Many birds are constantly active. Songbirds spend much of their day searching for food, defending territory, interacting with rivals, caring for young, or responding to changes in their environment. There is a constant sense of movement. Owls often appear different. An owl can spend hours perched in the same location. To a casual observer, it might even look bored. But researchers have learned that stillness itself can be a strategy. Every movement creates information. Every wing beat creates sound. Every shift in position consumes energy. By remaining motionless, an owl gains an advantage. It becomes harder to detect, easier to conceal, and better able to focus on the information coming from the world around it. It's a reminder that in nature, success isn't always about doing more. Sometimes it's about doing less. This becomes especially apparent when you look at how owls hunt compared to other birds of prey. A falcon relies heavily on speed. Some falcons can dive at well over 200 miles per hour, making them among the fastest animals on Earth. An eagle often depends on power and eyesight, spotting movement from incredible distances before descending with tremendous force. An owl takes a different approach. Instead of dominating its environment through speed or strength, it relies on precision. A successful hunt may be determined by a sound that lasted less than a second. A slight movement beneath grass. A tiny disturbance in a patch of leaves. A detail so small that most animals would never notice it. And yet, somehow, the owl notices. The more you learn about owls, the more you realize they are specialists in detecting things that would otherwise go unnoticed. Even their feathers contribute to this idea. Those feathers are not only soft and silent, but incredibly sensitive to airflow. As an owl moves through the air, subtle changes in wind conditions can be detected through the feathers themselves. Tiny adjustments are made continuously, helping maintain stability and control. The flight may appear effortless. In reality, countless corrections are happening every second. And perhaps nowhere is this more obvious than when an owl lands. Watch most birds come in for a landing and you'll see a brief moment of chaos. Wings flap rapidly, feet extend forward, balance shifts. Owls often seem almost impossibly smooth by comparison. They approach slowly. The wings spread wide. The speed decreases. And then, almost gently, they settle onto a branch as if they had barely been moving at all. It's one of those moments where the animal seems perfectly matched to its environment. The branch, the bird, the night, everything fitting together exactly as it should. And speaking of branches, many people are surprised to learn that not all owls actually live in trees. The image of an owl perched in a forest is certainly common, but the owl family is far more diverse than most people realize. Some species spend much of their lives in open grasslands. Others inhabit deserts. Some nest on cliffs. And one species, the burrowing owl, does something that seems almost completely unlike an owl. It lives underground. Rather than nesting in trees, burrowing owls often take up residence in abandoned burrows dug by prairie dogs, ground squirrels, or other animals. Imagine seeing an owl standing at the entrance of a tunnel in the middle of a grassy field. No towering trees. No dark forest. Just open sky stretching in every direction. It's a reminder that even within a group as recognizable as owls, evolution is constantly experimenting. Different habitats create different challenges. Different challenges create different solutions. And over time, entirely new lifestyles emerge. The snowy owl offers another example. When many people picture an owl, they imagine brown feathers blending into bark and shadow. A snowy owl looks almost like the opposite. Covered in brilliant white feathers, it seems built from winter itself. These owls spend much of their lives in Arctic environments where snow and ice dominate the landscape. Their coloration helps them blend into a world that would make a forest owl stand out immediately. What's fascinating is that younger snowy owls often have more dark markings, while older males can become increasingly white as they age. In a way, you can sometimes estimate a snowy owl's age simply by looking at the amount of white in its plumage. And that brings us to another interesting fact. Owls can live surprisingly long lives. In the wild, many face significant challenges and dangers, but some individuals survive for decades. Larger species often live longer than smaller ones, and in protected environments, certain owls have reached ages that would surprise most people. Think about that for a moment. Some owls alive today may have watched entire forests change around them. Trees growing taller. Storms reshaping landscapes. Generations of animals coming and going. Year after year. Season after season. Always returning to the same rhythms. The same nights. The same moonlit paths across the sky. And perhaps that's part of what makes owls feel so timeless. They seem connected to something older than our busy modern world. A quieter pace. A slower rhythm. A life measured not by clocks or calendars, but by sunsets and sunrises, by changing seasons, and by the gradual movement of stars overhead. Long after the daytime world has settled into sleep, the owl remains awake. Watching. Listening. Moving through the darkness with a kind of calm confidence that few animals possess. As if the night itself were a place it has known forever. As the hours of darkness pass, the owl's world continues to reveal details that most of us never think about. Take something as simple as an owl's feet. Most people notice the eyes first. Then the feathers. Perhaps the wings. The feet are usually an afterthought. But hidden beneath those soft feathers are some of the most specialized tools in the bird world. An owl's talons are designed not simply to catch prey, but to hold it with extraordinary force. Once the toes close around an object, tendons in the legs help maintain the grip with surprisingly little effort. It's an efficient system, allowing an owl to perch securely on branches for long periods without constantly straining its muscles. In fact, if you've ever wondered how birds can sleep while perched high above the ground without falling, part of the answer lies in these specialized tendon systems. As the legs bend and the bird settles its weight, the toes automatically tighten around the branch. Nature, once again, finding a way to save energy. And owls are masters of saving energy. This becomes especially important during winter. Imagine an owl perched on a snowy branch in the middle of January. The temperature is far below freezing. The wind occasionally drifts through the trees. Yet the owl remains remarkably comfortable. Part of this comes from feathers that extend farther down the legs than many people realize. Some species look almost as though they're wearing thick feathered boots. These feathers trap warm air close to the body and protect exposed skin from the cold. For Arctic species, this insulation becomes even more impressive. The snowy owl spends much of its life in environments where winter conditions would challenge most animals. Thick plumage covers nearly every part of the body, helping retain heat while temperatures plunge far below zero. Even the feet can be heavily feathered. It's a bit like wearing a down jacket, insulated pants, gloves, and winter boots all at once. And despite these harsh conditions, snowy owls remain active hunters. The Arctic may seem empty from a distance, but it contains a surprising amount of life. Lemmings scurry beneath the snow. Ptarmigans move across frozen landscapes. And overhead, the owl watches. What's especially fascinating is that not all owls experience darkness in the same way. When we think about owls, we often imagine moonlit forests and midnight hunting. But an Arctic summer changes everything. Near the North Pole, the sun can remain above the horizon for weeks at a time. Imagine an owl living in a place where night barely exists. For the snowy owl, that is completely normal. Instead of hunting under darkness, it often hunts beneath continuous daylight. The same animal family that became famous for nighttime activity has species that adapted to a world where the sun refuses to set. It's one of those reminders that evolution isn't following a strict set of rules. It adapts to circumstances. Wherever owls found opportunities, they changed to meet them. And some of those changes became surprisingly strange. The elf owl, for example, is the smallest owl on Earth. Standing only about 5 inches tall, it's shorter than many smartphones. Imagine all the features we've discussed: silent flight, sharp hearing, forward-facing eyes, nocturnal behavior, compressed into a bird small enough to sit comfortably in the palm of your hand. At the other end of the scale are species like the Blakiston's fish owl, one of the largest owls alive today. Its wingspan can stretch over 6 feet across. The difference between these two birds is enormous. And yet both are undeniably owls. Both carry the same evolutionary blueprint. The same forward-facing gaze. The same specialized hearing. The same adaptations refined over millions of years. As dawn slowly approaches, another interesting aspect of owl life begins to emerge. Unlike many birds that greet the morning with loud songs, owls often become quieter as daylight approaches. The nighttime shift is ending. The daytime shift is about to begin. Other birds will soon take over the skies. Songbirds will fill the forest with calls. Hawks will begin scanning open fields. The world will become brighter, louder, and more active. The owl knows this. Not consciously, perhaps, but through rhythms repeated across countless generations. And so it begins to seek shelter. A hollow tree. A dense cluster of branches. A hidden perch against a trunk. Somewhere it can disappear. And disappear it often does. Researchers studying wild owls frequently describe how difficult they can be to locate, even when they know an owl is nearby. The bird simply becomes part of the landscape. A shape among shapes. A pattern among patterns. A shadow among shadows. Perhaps that's one reason people encounter owls so rarely despite them living all around us. Many forests contain owls that most visitors never see. Many parks contain owls hidden in plain sight. Many quiet nights pass with owls overhead, completely unnoticed. Yet they are there. Watching. Listening. living lives that unfold largely beyond human attention. And maybe that's part of their enduring appeal. Owls remind us that there are entire worlds operating alongside our own. Entire lives unfolding in the darkness while we sleep. Ancient rhythms continuing night after night, year after year, largely unchanged. A hidden layer of nature that has always been there, waiting patiently for the sun to go down. As dawn remains just beyond the horizon, it's worth pausing for a moment to appreciate just how unusual owls really are among birds. Because despite looking somewhat similar to other birds of prey, owls evolved along a very different path. One fascinating example can be found in something most people never notice: the shape of an owl's face. If you've ever looked directly at an owl, you may have noticed that its face appears surprisingly flat compared to most birds. Hawks, eagles, falcons, and parrots all have faces that project outward. Owls seem different, almost human, in a strange way. That flat appearance isn't an accident. The facial structure evolved to support the owl's incredible hearing system. In some species, the facial disc can be adjusted slightly by tiny muscles, subtly changing how sound is directed toward the ears. It's almost like an owl can fine-tune its own listening equipment depending on what it's trying to detect. And speaking of ears, not all owl ears are hidden in exactly the same way. In species such as the long-eared owl and great horned owl, many people assume the feather tufts on top of the head are ears. They aren't. Those famous horns are actually just feathers. The real ears are located on the sides of the head beneath the feathers. Scientists still debate all the advantages these feather tufts provide. They may help with camouflage, communication, or breaking up the bird's outline against branches. Whatever their purpose, they create one of the most common misunderstandings in the animal kingdom. Millions of people have looked at an owl and mistaken decorative feathers for ears. Another surprising fact involves the owl's digestive system. Imagine swallowing a mouse whole. Bones, teeth, fur, everything. Most predators chew their food into smaller pieces before swallowing. Owls generally do not. Instead, they swallow prey largely intact and allow a highly specialized digestive system to separate what can be used from what cannot. The usable material is digested normally. The rest becomes something called a pellet. Several hours later, the owl regurgitates this compact bundle of fur, bones, teeth, feathers, and other indigestible material. It sounds unpleasant, but for scientists, owl pellets are treasure chests. Researchers and students often dissect pellets to learn exactly what owls have been eating. Entire food webs can be studied from the remains hidden inside a single pellet. In a strange way, owls have spent centuries collecting biological samples for scientists without even realizing it. Their nesting habits are equally interesting. Unlike many birds, owls are often surprisingly lazy builders. Rather than constructing elaborate nests from scratch, many species prefer to reuse existing structures. Some occupy abandoned hawk nests. Others claim tree cavities created by woodpeckers. Some simply settle into natural hollows that already exist. Why spend energy building a new home when a perfectly good one is already available? It's an efficient strategy, and owls seem quite happy to take advantage of it. Their eggs reveal another curious detail. Most birds begin incubating only after laying an entire clutch of eggs. Many owls start incubation immediately. This creates an unusual situation. The first egg hatches first. The second hatches later. The third later still. As a result, owl siblings can differ dramatically in size despite belonging to the same family. In some nests, the oldest chick may be several times larger than the youngest. Looking into an owl nest can sometimes feel like looking at birds of completely different ages. And then there are the migrations. Or perhaps more accurately, the lack of them. Many birds undertake predictable migrations every year. Owls often refuse to follow such simple rules. Some species remain in the same territory their entire lives. Others move only when food becomes scarce. Certain northern species occasionally produce what scientists call an eruption. In years when prey populations collapse, enormous numbers of owls suddenly move southward into areas where they are rarely seen. Birdwatchers can go decades without seeing a particular species, only for hundreds to appear during a single winter. The movement seems mysterious until you realize the owls are simply following food. Nature rarely wastes energy on unnecessary travel. Even their lifespan contains surprises. While many small birds live only a few years, some owls can survive for decades under the right conditions. Throughout that time, they become intimately familiar with their surroundings. Researchers tracking individual owls have discovered that some know their territories with astonishing detail. Every clearing, every stream, every favored perch. The landscape becomes a mental map built over years of experience. And perhaps that's one reason owls seem so calm. They inhabit worlds they know exceptionally well. A world of familiar sounds, familiar routes, familiar rhythms. Night after night, season after season, the same forests, fields, and mountains continue to tell their stories. And the owl continues listening. Not because the story is new, but because there is always another detail to notice. As the night stretches on, it becomes easier to understand why owls have developed such a powerful presence in human imagination. Not because they are the largest birds, not because they are the fastest, but because they seem to know things before anyone else does. An owl often appears aware of its surroundings long before there is any visible reason to be. It notices movement before movement becomes obvious. It reacts to sounds that seem impossibly faint. It turns its attention toward places that appear empty, only for something to emerge moments later. Of course, there is no mystery behind it. The owl isn't predicting the future. It's simply gathering information that most animals would miss. And nowhere is this more apparent than during the moments just before sunrise. At first, the change is almost impossible to notice. The stars remain visible. The forest remains dark. The air feels the same. Yet slowly, minute by minute, the world begins shifting. A little more light reaches the horizon. The temperature changes slightly. The sounds of the night begin to mix with the sounds of morning. For an owl, these changes are not subtle at all. They are signals. The landscape itself is announcing that another transition is underway. What's fascinating is how sensitive many animals are to these gradual changes. Humans tend to notice obvious events, a sunrise, a sunset, a storm rolling in. Owls often respond to changes long before they become obvious. Tiny increases in light levels can influence behavior. Slight shifts in temperature can alter activity patterns. The owl doesn't need a clock. The environment provides all the information it needs. And this connection to natural rhythms runs deep. Some scientists believe that one reason owls are so successful is because they are exceptionally tuned to patterns. Not conscious patterns in the way humans recognize schedules, but biological patterns that repeat over and over. The movement of prey, the cycle of seasons, the changing length of days, the phases of the moon. Even the moon itself seems to play an interesting role in owl behavior. Researchers have observed that some species alter their hunting habits depending on how bright the night is. A full moon creates a very different environment than a moonless sky. Shadows become sharper. Visibility improves. Prey animals may behave differently because they feel more exposed. The entire ecosystem changes, and the owl changes with it. There is something remarkable about that flexibility. When people think of specialized animals, they often imagine creatures that can only survive under very specific conditions. Yet owls somehow manage to be both specialized and adaptable at the same time. The same bird capable of hearing a mouse beneath snow can also adjust to changing seasons, shifting prey populations, and completely different habitats. That balance may be one reason they have endured for so long. Because the world has changed dramatically since the first owls appeared. Entire mountain ranges have risen and eroded. Ice ages have come and gone. Forests have expanded and disappeared. Countless animal species have evolved, flourished, and vanished. Through all of that change, owls remained. Not exactly the same, of course. Modern owls differ from their ancient ancestors. But the basic idea survived. A bird built for awareness. A bird that relies on patience. A bird that gathers information before acting. And perhaps that's why an owl sitting quietly on a branch can feel strangely timeless. It isn't doing anything extraordinary in that moment. It isn't hunting. It isn't flying. It isn't calling. It's simply observing. Yet hidden inside that stillness are millions of years of refinement. Millions of years spent perfecting the ability to understand what is happening in the world around it. And maybe that's the most impressive thing about owls. Not their eyes. Not their hearing. Not even their silent flight. It's the way all of those things come together to create an animal that seems perfectly at home in a world most creatures find difficult to navigate. A world of shadows, of faint sounds, of subtle changes. A world where success belongs not to the loudest or strongest animal, but to the one paying the closest attention. One area of owl biology that scientists are still actively studying involves something surprisingly simple. How an owl knows exactly where it is in space while flying through complete darkness. Imagine trying to move through a forest at night. Not a brightly lit trail. Not a moonlit clearing. A genuinely dark forest where branches, trunks, and obstacles surround you on all sides. For most animals, vision alone would not be enough. Yet owls routinely navigate these environments with remarkable precision. Part of the answer lies in a process called sensory integration. The owl's brain is constantly combining information from multiple sources at the same time. Sound, vision, balance, airflow, body position, and movement are all being processed together. Humans do this too, but owls appear to have taken it to an extraordinary level. When an owl flies, it isn't simply reacting to what it sees. Its brain is continuously updating a three-dimensional model of the environment around it. Tiny changes in sound help identify obstacles. Visual information confirms locations. The inner ear monitors orientation and balance. All of these systems work together so seamlessly that the owl can move through cluttered environments without hesitation. What's especially fascinating is the inner ear. Most people think of ears as hearing organs, but part of the inner ear is dedicated to balance. Inside are fluid-filled structures that detect acceleration, rotation, and head movement. Without them, maintaining stable flight would be nearly impossible. Every time an owl banks, turns, dives, or lands, these structures help keep track of its position. And because owls perform many of these movements in darkness, their balance systems are exceptionally important. Scientists have also discovered that owl brains contain specialized regions devoted to creating spatial maps. These areas help connect sounds to physical locations in the environment. A noise isn't simply recognized as a noise. It becomes associated with a position in space. A moving mouse isn't just heard. It is placed onto an internal map. And that map updates continuously. Another fascinating area of research involves owl feathers and airflow. For years, scientists focused primarily on the silence of owl flight. More recently, researchers have become interested in how owls maintain such precise control at low speeds. Many birds perform best while moving relatively quickly through the air. Slow flight can become unstable and difficult to control. Owls somehow remain graceful even when flying very slowly. Part of the reason appears to be the structure of their wings and feathers, which allow smooth airflow across a wider range of speeds. This gives them remarkable maneuverability when moving through forests filled with obstacles. Some engineers have even studied owl wings while designing quieter aircraft, wind turbines, and drone technology. It turns out that millions of years of evolution can produce solutions that modern engineering finds surprisingly useful. Another interesting scientific mystery involves the owl's facial disc. While we know it helps direct sound toward the ears, researchers continue discovering just how sophisticated the system may be. Certain species appear capable of subtly altering the shape of the facial feathers depending on what they are listening to. It's a small adjustment, but one that could potentially improve sound collection under different conditions. In a way, the owl's face functions as both a hearing device and a communication system. Different feather positions can influence how the bird appears to other owls while simultaneously affecting sound reception. The deeper scientists investigate, the more multifunctional these structures become. And then there is metabolism. Despite spending long periods sitting still, owls maintain a surprisingly active internal physiology. Like all birds, they are warm-blooded animals with relatively high metabolic rates. Their hearts beat rapidly compared to similarly sized mammals, and their respiratory systems are incredibly efficient. Bird lungs work very differently from human lungs. Instead of air moving in and out through expanding sacs the way it does in mammals, birds use a system of air sacs and one-way airflow that allows oxygen extraction to remain highly efficient. The result is a constant flow of fresh air through the respiratory system. For an animal that depends on flight, this efficiency is invaluable. Every wing beat requires energy. Every hunt requires oxygen. And every improvement in efficiency increases the chances of survival. Perhaps one of the most surprising scientific discoveries about owls is how much they reveal about evolution itself. When people imagine evolution, they often picture dramatic transformations. But owls demonstrate something different. They show how small improvements can accumulate over millions of years. A slightly quieter feather, a slightly better hearing system, a slightly more flexible neck, a slightly more efficient wing. None of these changes would seem extraordinary on their own. Yet over immense stretches of time, they combine into something remarkable. An animal capable of hearing sounds beneath snow, flying almost silently through darkness, navigating forests at night, tracking prey with astonishing precision. Not because of one incredible adaptation, but because dozens of good adaptations gradually became exceptional ones. And perhaps that's what makes owls such a fascinating subject of study. The more closely scientists examine them, the less they seem like a collection of separate features. Instead, they appear as a perfectly integrated system, where every part contributes to the same goal: understanding the darkness in ways few other animals can. One question that scientists have asked for decades is whether owls are born with all of their remarkable abilities, or whether some of those skills have to be learned. The answer turns out to be somewhere in between. A young owl enters the world with many of the tools it will need later in life. The hearing structures are already developing. The eyes are already specialized for gathering light. The instincts that guide hunting behavior are present from the beginning. But possessing the tools and knowing how to use them are very different things. Researchers observing juvenile owls have discovered that young birds often make mistakes that experienced adults would never make. They misjudge distances. They choose poor perches. They launch attacks too early. Sometimes they miss entirely. This might seem surprising when discussing an animal so perfectly adapted for hunting, but it reveals something important. Even among highly specialized predators, experience matters. An owl's first year of life can be filled with trial and error. Over time, those mistakes become lessons. The bird learns how different sounds behave in different environments. It learns how wind affects flight. It learns which hunting areas are productive and which are not. In many ways, an older owl carries something that no young owl can possess: a lifetime of accumulated information. And information is perhaps the owl's most valuable resource. What's fascinating is that owls often remember locations with remarkable consistency. Studies tracking individual birds have found that many return to the same perches again and again. Certain branches become favorite observation points. Certain hunting routes become familiar. The landscape slowly transforms into a detailed mental map. Imagine spending years exploring the same forest. Eventually you would know every trail, every clearing, every stream crossing, every unusual tree. For an owl, the process is similar, except much of that map exists in darkness, built not only from sight, but from sound and experience. Another area of owl science that continues to intrigue researchers involves sleep itself. This may seem ironic for an animal that spends so much of its life awake at night, but owls actually provide valuable insights into how sleep works in birds. Like many other bird species, owls experience different sleep stages, including forms of sleep that resemble the REM sleep seen in humans. During these periods, brain activity changes, and scientists believe important processes involving memory and learning may be occurring. In other words, the owl's brain may spend part of the day organizing information gathered during the night. The sounds, the locations, the experiences, all being processed while the bird rests. And speaking of resting, there is another surprising fact hidden beneath an owl's feathers. Despite their reputation as fierce predators, many owls spend a surprisingly large percentage of their lives doing very little. Not because they are lazy, because efficiency works. A successful owl does not need to constantly search for opportunities. It waits, observes, conserves energy. When the moment arrives, it acts. Then it returns to stillness. This strategy may seem simple, but it has proven extraordinarily effective. Nature often rewards efficiency far more than effort. And owls are living examples of that principle. Scientists have also discovered something fascinating about how owl populations can reveal information about entire ecosystems. Because many owls sit near the top of local food chains, changes in owl numbers can sometimes signal changes occurring throughout the environment. If prey populations decline, owls may struggle. If habitats disappear, owl territories may shrink. If ecosystems become healthier, owl populations often benefit. In this way, owls sometimes function as biological indicators. Their presence tells scientists something about the health of the world around them. A thriving owl population often suggests that many other parts of the ecosystem are functioning well too. It's a reminder that owls are not isolated creatures. They are connected to everything around them. The mice beneath the leaves, the insects in the grass, the trees providing shelter, the weather patterns affecting prey, the changing seasons. Every part influences every other part. And perhaps this is one of the most beautiful lessons hidden within owl biology. The owl appears solitary, independent, self-contained. Yet its survival depends upon countless connections stretching throughout the environment. Nothing exists entirely alone. Not even one of nature's most independent hunters. As scientists continue studying owls, new discoveries appear every year. Better tracking technology reveals migration patterns that were once invisible. Improved imaging techniques uncover details of anatomy that earlier generations could only guess at. Tiny sensors provide information about flight, movement, and behavior that would have seemed impossible to collect only a few decades ago. And despite all we have learned, owls still hold mysteries. There are behaviors not fully understood. Adaptations still being investigated. Questions that remain unanswered. Which may be fitting. After all, few animals seem better suited to keeping a little mystery than an owl. A creature that spends much of its life moving through darkness, quietly gathering information, while revealing only a small part of its own story in return. As researchers began attaching tiny tracking devices to wild owls, they discovered something that would have been almost impossible to learn through observation alone. Many owls live much larger lives than people imagine. For centuries, humans mostly encountered owls in brief moments. A silhouette crossing a road at night. A distant call from the woods. A pair of eyes reflecting light from a flashlight. It created the impression that owls rarely moved very far. But some species regularly travel enormous distances. not in the predictable way geese migrate south every winter, but in response to changing conditions. Food availability, weather patterns, population cycles, and habitat changes can all influence movement. One year, an owl may remain in the same territory for months. The next, it may travel hundreds of miles. Scientists call some of these events eruptions. Every few years, particularly in northern regions, food populations can fluctuate dramatically. When this happens, large numbers of owls suddenly appear far outside their normal range. Birdwatchers become excited. Researchers begin tracking reports. Communities that rarely see owls may suddenly find them appearing in parks, fields, and forests. To the public, it can seem mysterious. But from the owl's perspective, it's simply a response to changing resources. Follow the food. Adapt to the environment. Keep moving if necessary. It's a strategy that has worked for millions of years. And speaking of millions of years, one of the most fascinating questions scientists ask is what the first owls were actually like. The oldest known owl ancestors lived tens of millions of years ago, in a world that would look very unfamiliar to us. The continents were arranged differently. Many modern mammals had not yet evolved. Entire ecosystems existed that have long since disappeared. Yet fossil evidence suggests that even these ancient owls already possess some of the features we recognize today. Forward-facing eyes, powerful talons, specialized hunting adaptations. The blueprint was already there. Of course, they weren't identical to modern owls. Evolution continued refining them. Different branches of the owl family experimented with different lifestyles. Some became larger. Some became smaller. Some adapted to forests. Others adapted to grasslands, deserts, mountains, and tundra. Over vast periods of time, the owl family diversified into hundreds of species. And yet when you look at an owl today, there is still something ancient about it. Something that feels unchanged. Perhaps it's the eyes. Perhaps it's the silence. Or perhaps it's the simple fact that an owl is doing many of the same things its ancestors did millions of years ago. Listening. Waiting. Watching. Another fascinating area of research involves the owl's remarkable ability to judge distance. Humans rely heavily on binocular vision. Because our eyes face forward, each eye sees a slightly different image. The brain compares those images and calculates depth. Owls use the same principle. Their forward-facing eyes provide excellent depth perception, which is essential when striking prey with precision. Imagine attempting to grab a moving object in complete darkness while flying. A small error in distance could mean a missed opportunity. The owl's visual system helps reduce those errors. But what's particularly interesting is how the owl combines depth perception with hearing. Scientists have found that owls don't rely entirely on one sense or the other. Instead, the brain merges information from both systems. Sound suggests a location. Vision confirms it. The two work together. It's another example of how interconnected owl biology really is. Nothing operates alone. The ears support the eyes. The eyes support movement. Movement supports hunting. Everything contributes to a larger system. Even the owl's feathers continue to surprise researchers. When viewed under powerful microscopes, feathers reveal incredibly complex structures. Tiny barbs interlock with one another, creating lightweight yet durable surfaces capable of withstanding years of use. In owls, these structures become even more specialized. The same feathers that reduce noise also help manage airflow, insulation, and waterproofing. A single feather performs multiple jobs simultaneously. And when multiplied across thousands of feathers covering the body, the result is one of the most sophisticated flight systems in nature. There is also something remarkable about how resilient owls can be. Wild animals face countless challenges throughout their lives. Storms, injuries, competition, food shortages, harsh winters. Yet many owls continue adapting to these changing conditions year after year. Not because they are invincible, but because flexibility is often more valuable than perfection. An owl doesn't need every hunt to succeed. It doesn't need every season to be easy. It simply needs to survive long enough to try again tomorrow. And perhaps that's one of the most overlooked lessons hidden within the science of owls. Their success isn't built upon constant victory. It's built upon consistency. Night after night. Season after season. Generation after generation. Small advantages accumulating over time. Tiny improvements repeated again and again. Until eventually those advantages become one of the most successful groups of nocturnal hunters on Earth. And as the stars slowly begin fading above the horizon, the owl remains part of a story that began long before humans ever looked up into the darkness and wondered what was watching from the trees. A story still being written every single night. And as our journey through the world of owls begins to come to an end, it's worth returning to where we started. A quiet forest. A fading sunset. The moment when most of the world begins settling down for the night. Because while owls may seem mysterious, what makes them truly remarkable isn't that they're hidden from us. It's that they've been here all along. For thousands of years, people have looked into the darkness and heard their calls drifting through the trees. Generations have watched silent shapes pass beneath the moon and wondered what kind of creature could move through the night with such ease. Now we know a little more. We know about the extraordinary eyes that gather the smallest traces of light. We know about the ears capable of detecting sounds too subtle for us to notice. We know about the feathers that transform flight into near silence, and the remarkable anatomy that allows an owl to rotate its head and survey the world around it. We know that beneath the mystery lies an incredible collection of scientific adaptations, refined over millions of years. And yet somehow, even after learning all of that, owls still feel mysterious. Perhaps because they remind us that there are entire worlds operating alongside our own. Worlds that become active when we sleep. Worlds filled with sounds we don't hear, movements we don't see, and lives that unfold quietly beyond our attention. Right now, somewhere, an owl is perched on a branch. Maybe deep within a forest. Maybe in a field. Maybe on the edge of a town where people have no idea it's there. Its golden eyes are scanning the darkness. Its ears are gathering information from every direction. The night is alive with details. And the owl is reading them all. Not rushing. Not forcing anything. Simply existing within a world it understands perfectly. There is something calming about that. The idea that nature doesn't always depend on speed. That survival isn't always about being the strongest, loudest, or fastest. Sometimes it comes from patience. from awareness, from paying attention to things that others overlook. The owl has spent millions of years perfecting that approach. Night after night, season after season, generation after generation. And long after this evening ends, long after the last stars disappear and the first light of morning reaches the treetops, owls will continue doing what they have always done. Watching, listening, waiting, moving silently through the darkness beneath the same moon that has guided countless generations before them. And perhaps tomorrow night, when the sun sets once again and shadows begin stretching across the landscape, another owl will emerge from its hidden perch. The forest will grow quiet. The daytime world will fade. And somewhere among the trees, a pair of eyes will open to greet the night. Thank you for joining me on tonight's journey through the fascinating science of owls. And until our next adventure together, sleep well, stay curious, and as always, keep wondering about the hidden worlds all around you.